Hey everyone, can you all hear me? Can somebody give me a thumbs up or a comment? Hey, thank you, Deepanshu. Hey, thank you very much, everyone. Wonderful. Well, welcome to today's session. I'm gonna get my window share in here, and thanks everyone for joining us today. This is one of my favorite things to do is to run these API security workshops. Definitely let us know where you're joining us in the world here today, and love to see all the comments here in the chat. So this is what we call our API security workshop, which is something that we started doing earlier this year. It's um, it's something we've done probably 50 plus times privately for different organizations, and we thought, well, why not do this for the world at large? So thank you all for joining us. We've got something like 2,500 people registered for this session. And what are we going to cover here over the next hour? There's a lot to cover, and it's really broken into three sections. First section, we're going to talk about why are APIs under attack? What makes APIs so appealing to attackers? We're going to move into real world breaches. We're going to talk about what's happening out there, real examples of breaches, and we're going to map those over to the OWASP top 10. And then in the third section, we're going to talk about like, hey, what can you do to better protect your organizations, keep your APIs safe and secure? Love all these comments coming in here. Welcome, everybody. And let's dive right in. One of the new things that we've got here, this was Christine's idea, is we now offer certificates of attendance. So stick around for the whole hour. We'll send you a link, or we'll share a link where you can apply to get your certificate of attendance. Credly badge, you can post it on LinkedIn, earn CPE credits as well. So stay tuned for that. We won't post the link until the very end there. And of course, most of you probably, probably all of you perhaps are familiar with APIsec University. If you're not, I highly recommend you come check out our site. We've got a bunch of great content out there. Over here on the far right is our most recently added course, API authentication. We launched that about a month ago or so. Phenomenal content, but you see all of our courses, and big news, we're about 2 weeks away from the much anticipated LLM and AI course. And we're really excited to get that launched here. So probably at the end of the month, beginning of August, you can expect us to have that AI course live for you all here as well. All right. So let's dive into what we're here for. All right. So the first section is why are APIs under attack? Right. And so to get things started, three stats. All right. First stat is 83%. Right. Some of you may already know this. That is what percent of the internet's traffic is API powered. This is from Akamai. They analyzed all the traffic on their network. This is 3, 4, 5 years ago, and they found 83% of all that traffic was APIs. Some people tell me it's north of 90%, but whatever the number is, it's a big number, right? And it's really testament to how APIs have just exploded. They're really powering every website, every mobile app, every microservice. Fantastic technology, and the adoption really proves that out. Number one, though, is where API attacks now rank. This is a quote from Gartner Group. They were predicting that by 2022, API attacks would become the number one most frequent attack vector. You will see that that is definitely true. Certainly the most successful attack vector, right? And then 4% represents kind of the state of affairs for our API security testing, right? This is a survey from Rapid API. They queried their million user audience and asked them, what kind of testing are you doing on your APIs? 96% is positive testing. Does it work? Does it perform? Is it fast? Is it bug free? Way down at 4% security testing, right? Way, way, way too low. There are reasons why that number is too low. The technologies haven't kept up. We have a high reliance on manual testing. And so these three stats are really creating a perfect storm for API breaches to happen. Okay. So, but what is it about APIs that are so appealing for attackers, really? And it's really quite simple, right? If you look at where APIs sit in your ecosystem, right? It is literally the plumbing. It's the connective tissue that takes requests from your front ends, the mobile apps, the web apps, and passes them through to the back end. It is this direct path between the outside world to your inside world, right? And it connects those UIs to back end data, to functionality, to transaction engines, to microservices, and so forth, right? And if there are any flaws that exist at that API layer in how they're configured, the logic, the authorization rules, and so forth, those become exploits or vulnerabilities for you, right? And those APIs, even if you aren't publishing them or creating a developer portal, they are very discoverable. In fact, a lot of folks think that their APIs are kind of hidden and no one can find them. It's actually exceptionally easy to find them. And just to give you a feel for how easy, I just went to United Airlines. I'm not picking on them. This would work on any website out there. You can see I'm checking some flights, some fares. If I want to find the APIs, all I got to do is in my browser, right click. I'm using Chrome here. Click on inspect. And this pops up this console, right? I can click on the network tab at the very top. You can see I put API in the search bar. I've selected the headers area down below, and there you go. There's the API call, fetch flights, right? And that's what's returning this data into this view. No special technologies. I didn't have to sniff traffic or do any man-in-the-middle type stuff, right? These APIs are very visible, right? And that's not wrong. That's just how the internet works, right? But don't think that your APIs are protected because somehow they're not visible. But let's talk about how almost every API attack works. Okay, so this is a very simple. All right, I'm seeing some screen issues. Are you guys seeing my screen all right? How APIs get attacked? Can I get a thumbs up or something? All right, thank you, Essie. All right, so this is how virtually every attack happens, right? So you've got your front end, communicates through a bunch of APIs to the back end, right? And historically, we've put a lot of security and controls at that front end. That's what this yellow box is kind of depicting, right? It's where we authenticate users, we filter data, we only show certain buttons and features depending on your permissions and roles and so forth. We do our web app scanning and all that kind of stuff here at the front end. And if you think about the front end, it's a highly controlled environment, right? I can only do certain actions based on what you present to me. Okay. Now, here's what attackers do, right? They go to your UI, they click every button, they fill out every field, use every feature that they can find. And then they watch the traffic between your front end and the back end, and they find all those API calls, right? And then what they do is they go right around your UI and they hit the API directly, right? And if you think about the API, it's a very uncontrolled environment, right? There's no UI, it's a command line, and you can literally write any request you want and send it. Nothing's going to stop you from doing that, right? So this is why APIs are so appealing from an attacker's perspective, right? There's a lot more possibilities, a lot more things you can try at the API layer that you cannot do at the UI. And what they often find at the API layer are APIs that are over permissioned. They return more data than you want to expose to the outside user. They expose functionality that you might not want users using, exposes logic flaws. All kinds of things are possible at the API layer, even if they are not possible at the UI. So this is the fundamental reason why APIs are under attack here. Okay, so let's talk about some real world examples here, right? So I'm going to give you a bunch of examples here. I actually have set up an API breach Google alert. It fires almost every day, certainly every week. This one was from back in May. It was kind of fun. These college students hacked their laundry machines in their dorm rooms and gave themselves free laundry for life, right? All through hacking the API of that laundry machine service, right? So that's kind of a fun example, although not so fun for that organization losing revenue. But here's maybe the more serious side. These are all API breaches, every single one of these that you see here on this screen, right? And what stands out is just the sheer volume of examples, the These aren't little small companies that aren't sophisticated, that don't have the best technology. These are very sophisticated organizations. And somehow these API attacks are getting through the defenses, right? And we're going to talk about why that is. And look at the number of records, million, 10 million, 100 million records, right? APIs are great at high speed, high velocity, interactions. And that's great for attackers as well, right? You don't lose 10 or 100 or 1,000 records. You can lose 100 million through leaky APIs. So what we're going to do is unpack a few of these, and we're going to expand on what happened, and we're going to link those to the OWASP top 10. So imagine most of you are familiar with OWASP organization, the Open Web Application Security Project. It's a nonprofit. They've produced some really fantastic industry standard guidance on how to secure your web apps, your mobile apps. And in 2019, they saw the need to create an API specific top 10 here. Okay. And that's what you see here. Actually, they updated it in 2023. And excuse me, rather than go through this list kind of line by line, which is a little bit, sorry, thank you, Garth. I always get that wrong. Open Worldwide Security Project. I want to give you some stories, right? And it's going to really reinforce why this top 10 is the top 10, right? I think the OWASP organization really got it right here with this. And if you want to go deep into this, we have a really great course from Corey. We have OWASP API Top 10 and Beyond. It goes into a lot of detail. If you want to really understand API, the OWASP Top 10, we even have a certification called CASA that will test your knowledge of this as well. But let's dive right in here, okay? So first example is Coinbase. Some of you may have seen me present this before. It's a really outstanding example of what can happen with APIs, right? So here there was a hacker. He wanted to poke around the Coinbase platform and see if they could find any flaws or vulnerabilities. And like a good hacker, first thing they did was just go to the homepage, click every button, utilize every feature, created an account, deposited $1,000, started trading, and watched all the traffic between their browser and the backend, and identified all these API calls. And what you see here on this screen is what that traffic looks like when you do a trade, right? And here in yellow, you can see the parameters of the trade. The base size, 0.024, that's the quantity, right? Price of 3,000. The product is what he's selling, Ethereum on the European market. He's on the sell side, not buy side in this transaction. And then you see a source account, target account. Okay. This is what it takes to do a trade. Now, like a good hacker, the next thing he did was get rid of the UI and start sending commands, sending requests directly on the API itself. And one of the things that attackers like to do is send kind of intentionally ridiculous or erroneous requests to see what kind of error messages come back from the server. Sometimes we reveal useful things like what kind of parameters, what kind of data, what database is running, the tech stack, and so forth. So he crafted this request, but then wanted it to return an error. So you see here that he's selling Ethereum on the European market. He actually owned that, right? So he backspaced over the Ethereum and wrote Bitcoin instead, which he did not own. Okay, hit submit and waited for the error to come back, but didn't get an error. What came back was a trade confirmation. And as you can see here, his $1,060 of Ethereum sold as $43,000 of Bitcoin. And it actually worked, right? He probably thought he was going to prison at that point. Went on to Twitter and said, hey, does anyone know the CEO's email? Because this is potentially market nuking, this flaw. And really, that's not hyperbole. That is definitely a legitimate view of things. And Coinbase gets a ton of credit in my book. They immediately responded. They shut down the market, reproduced the issue, and then blogged about it a week later and said, look, this is what happened, right? We had the root cause was we had a missing logic validation check in the brokerage API endpoint. Okay. And what does that mean? When this request came in, that back end was checking, does Does this person actually own 0.0243 units of something? Yes. And it went ahead and processed it. It did not check what he owned or what he was trying to sell. That's the missing logic check, right? And if you think about this, this type of attack could never have been done at the UI layer. Impossible, right? There's no button to sell your Ethereum as Bitcoin, right? That's not possible. But at the API layer, you can craft any request you want and send it. And in this case, it actually worked, right? So the pro tip here is your UI is not part of security. It's very convenient. It's a very nice way to control what people can do. But as you can see here, if your attacker can bypass the UI, they can bypass those controls too. So we got to think about security at the API layer, right? Not just at the front end layer. Okay, so that's Coinbase. Next example is Peloton. This is the exercise bike. So here there was another researcher. They poked around the Peloton application. They watched all the traffic and they found all these API calls. And one of them, or at least one of them, was left wide open, meaning anybody could query this API with no credentials, right? And this particular API endpoint had access to the entire 4 million user Peloton database, even Joe Biden's records. Even if your records were marked as private, your records were still available to this API endpoint. So after some disclosure and some encouragement, Peloton went and fixed this, right? And what did they do? They took that open unsecured endpoint and they locked it down, right? So now you can't query it anonymously. The problem was anybody can go create a Peloton account. It doesn't even cost you any money. And you can use those credentials, access this endpoint, and you still had access to 4 million users' records, right? So they solved the authentication problem, but missed on the authorization problem, right? Authentication is Dan, right? Authorization is, can Dan access Christine's records, right? And that was the issue here with Peloton. So Coinbase and Peloton are great examples of OWASP number one, as well as others. But what I'm focusing on here is OWASP number one, broken object level authorization, or BOLA. This is number one for a reason. It's the biggest issue that we see out there for APIs. And the classic example is, can user A access user B's data, right? As we saw at Peloton. Or in the case of Coinbase, can I trade on an object, Bitcoin, that I don't own? That's an authorization flaw. They should have checked, right? And before processing that transaction, determined whether or not that was a valid request. There's a lot more detail here. This is the kind of information that's covered in the OWASP course. We don't have time to go through it all here, but if you want to learn more, please come. Found one that was left wide open, meaning with no credentials. And if you supplied the right email address, or any email address for that matter, it would respond to you with whether it's an active Duolingo user and everything about that user, right? So I myself am a Duolingo user, so I hacked myself, and this is no joke. The exact what happened. This is exactly what happened. You didn't even have to do this from a command line, which I wouldn't even be smart enough to know how to do. You could just go to this URL, put email equals, and then your email address. That's my actual email. And with no challenge, it responds with all of this information, right? Now you can see I have a 600-day streak. I'm trying to learn Italian, all that good stuff, right? And the remarkable thing here was all this was available with no challenge, no security, no check whatsoever, right? And you can Google this up. Duolingo's response initially was, what's the big deal? There's nothing valuable here, right? No home address, bank account. That's true. But this is actually golden information for a phishing campaign, right? Like I tell my kids, like imagine you get an email that says, congratulations, 100-day streak. Here's a special gift. Click here, right? You have all of this information available for you to do right here. And thank you, Daniel. It's actually closer to 900 at this point, but I still can't speak Italian. So, there you go. All right. So that's Duolingo, right? And this is the pro tip here is, why would you leave an API like that open, right? There's really no good business reason to have an unsecured endpoint like that. And my theory on this is, number one, we have constant pressure on developers to push out new code and features and bug fixes and all that kind of stuff. And there isn't always time to think about every security implication. And the other factor is there is this perception, a myth, that APIs are hidden and behind the scenes and no one can find them, right? And we've already seen that that's not true, right? So don't assume your APIs are safe because they're hidden, right? They're not hidden, right? Um, so this is a good example of broken authentication. OWASP number two. Number two for a good reason. We see lots and lots and lots of examples. You've already seen two of them, Duolingo and Peloton, right? And it's defined as weak or poor authentication. So like, you know, short password, no captcha, credential stuffing, all that kind of stuff. But to be honest with you, what I see more often than not is no authentication, right? Like APIs are just left with the door unlocked and anybody can come in and use it, right? So make sure you aren't making life easy on your attackers, lock the doors and make sure you have those authorization controls. Okay, next example is Venmo. And apologize, I'm talking so fast. There's just so much to cover here today. You can always watch the replay at slower speed if you like. But Venmo is the payment platform, right? And they had a feature on the homepage. It's kind of a social payment. So on the homepage, it would show you the last 10 or 20 transactions in real time. And of course, it was anonymized data, right? So it might have my first name, but no last name and things like that, right? No transaction details, bank information. But here there was an attacker that poked around, saw that feature, discovered the API call that was powering it. It was a public endpoint, no authorization needed. All right, so that's another example. But here's the key. When they queried the API directly, it did not return anonymized data. It returned the whole record, every field, all of it, right? And so what did they do? They wrote a script and they harvested 207 million transactions out of Venmo in full detail, right? They even made websites to track drug dealing and so forth on the Venmo platform by looking at keywords, right? So it probably took months for them to do this, but they just stayed under the radar and harvested all this data, right? So the pro tip on this one is do not filter data in the UI, right? Filter it at the source. They should have made a special API specifically for use of the homepage that only returned first name and not last name and not anything else, right? There's this concept of least information required, especially in open banking. Don't return a single field more than is needed, right? That's just creating extra exposure for you. And so this is a good example of broken object property level authorization. It's kind of a complicated title. I like the old title better, excess data exposure, right? That's what this is, right? This is an API that is returning more information than is necessary for the business case, right? So really, adhere to that concept of least information. Don't expose any more than you need to. Okay, next example is Trello. This is actually from earlier this year. If I wanted to invite you to my Trello board, there's a feature for that naturally, right? And I can give them your email address and some backend process will send you an invitation. Well, it turns out that backend process is powered by an API as it should be. And that API was publicly available, again, with no credentials required, open, unsecured, right? So if I submit an email to that endpoint, Trello would respond and say, is this a Trello user and everything about that user? Kind of just like Duolingo, actually, right? So what did this attacker do when they found it? Well, they went on the dark web and they grabbed 500 million email addresses from prior breaches and then sent 500 million requests to that endpoint to see who's a Trello user. And they found 15 million matches. And what you see here on this screen is they're posting on the dark web, selling 15 million Trello accounts with emails and usernames, full names, account details. Everything that you see here is what they were selling, all harvested from this open API, right? And so what stands out about this attack is the 500 million requests, right? You got to think like 500 million requests are going to be detected and blocked and all of that kind of stuff. But that didn't happen here. And why? Well, your attackers know you have WAF and you have rate limiting and all these kinds of things. And what do? They they ratcheted up their requests until they started getting denied, and then they backed it off by 10% and left it there for months at a time and rotated IP addresses and distributed their requests across, using residential proxies and the like, right? The main point out of all this is that rate limiting, while important and you should do it, right, is not going to necessarily deter a determined attacker, right? They've got all the time in the world, right? They can take months to execute their attack if they need to, right? And this is a good example of OWASP number 4, unrestricted resource consumption, right? Whenever we see millions of records being harvested, it suggests that some sort of volumetric brute force attack has succeeded, right? And what do you take away from this, right? Well, you might conclude that what Trello should have done was, made their rate limiting even more strict and or restrictive, right? But all that would do is frankly just slow down the attacker and maybe start to impact legitimate traffic on the Trello servers, right? And as we know, like attackers can just take as long as they want, right? So the if you think about what did Trello actually do here as a response, it wasn't like take that rate limiting and make it tighter and more restrictive. Actually, what they did was they took that open unsecured endpoint and locked it down. Right. So now you can't query it anonymously and distribute across thousands of different IP addresses. Now you have to authenticate, and it's way easier to detect abuse of 500 million requests from Dan than 500 million anonymous requests. Right. So literally just by locking down that endpoint as they should have, now they can actually mitigate this type of abuse in the future. So let me give you 2 more examples before we move on here. And thank you, Alex. I invite you to go check out the whole OWASP course if you want to see this, learn this in more detail. But the next example here is Bumble, dating website. And they had issues with unsecured endpoints, user A able to access user B's data, excess data exposure. But what makes this OWASP 5 is they also expose functionality that shouldn't have been available to end users. And in particular, with Bumble, you have free accounts and you can have paid accounts or premium accounts, right? So it's okay to have an API call where I would perform a GET request, a lookup to say, what type of account do I have? That's legitimate, right? But what they also exposed was a put and post method on my account type endpoint, meaning I can not only look up what type of account I have, I can modify it and say, I'm not a free account. I am a paid account or a premium, or who knows what else, an admin, who knows what else could have been possible there, right? And that is an example of API number 5, broken function level authorization, right? With OWASP 1, we talked about data authorization, like can I access other users' data? With 5, it's what functions can I perform, right? Like imagine you're like a bank, right? And you offer an auto loan, right? It's okay for the user to look up what's their balance, but they shouldn't be able to say, my balance isn't 10,000, it's 0 or negative 10,000, right? That's obvious functionality you wouldn't want to expose to users, but that's what we're talking about here. You need to control what functions users can control as much as what data they can access. Okay, and my last example here is Instagram, right? So let's say you wanted to take over Taylor Swift's Instagram account. Here's how you could do it. It doesn't work anymore, so don't try. But here's how you could have, right? You would go to Instagram, you would pretend to be Taylor Swift, and you'd say, I forgot my password, send me a reset, right? And Instagram would send a 6-digit code to the real Taylor Swift, which you would not get. But it turns out there's an API where you can submit your guess. And APIs are great for scripting. But Instagram had some controls, 10-minute timeout. And after 200 guesses, it would stop working for you. And at that point, this hacker probably thought they were kind of done, wasn't going to work. But they tried one last thing, which was they rotated their IP address. And to their surprise, they got 200 new guesses. So they just kept rotating IP address over and over and over, easily done within 10 minutes. And they could just start at 1 and make their way up to 1 million, and they would eventually find the right reset code for Taylor Swift or any user on Instagram for that matter, right? So this is a good example of OWASP API number 6, which is unrestricted access to sensitive business flows. And I really think this is an important one because it introduces the concept of business logic, right? Like we tend to think about as developers, as product owners, as operators, does our service work as designed, right? And if it does, great. We ship it, we publish it, we go to production, right? But as security teams, as developers, we need to think about how could that logic be abused, right? In this case, the reset logic worked. If I was Taylor Swift and I forgot my password, this would have worked, right? I could have reset my password. But I could also abuse this logic, this functionality to take over Taylor Swift's account, right? And in this case, so the moral of the story is think about your business flows and how they could be abused and misused and manipulated to cause harm for your organization. In this case, there were a lot of things that Instagram could have done. IP address is irrelevant to the equation. They should have, I don't know how that entered into how many guesses you should get. 10-minute timeout is okay. 200 guesses seems way too much. 4 or 5 is plenty, and then expire the code. It's no longer valid. And one of the things that would have, that could really have helped is don't use a numerical sequential reset code, right? By doing that, Instagram was basically saying, hey, hackers, the reset code is somewhere between 1 and a million. Good luck finding it, right? If you just made it alphanumeric, now it's almost impossible. You can't just increment and find your way through. So don't make life easy on your attackers, right? Stay away from incremental IDs if you can avoid it. Okay. In the interest of time, I'm going to sort of skim through the rest here. Again, you can go to our course and learn all about the top 10. But OWASP 7, server-side request forgery, SSRF, this is really all about input validation, right? So imagine you have an API where you ask the user to provide their home address, email, phone number, LinkedIn profile URL, and so forth. And imagine that URL from LinkedIn, they don't put a LinkedIn URL, they put in a SQL injection or a malware website or /localhost user data or something like that, right? You got to check every input to your API and make sure it matches what you're expecting. And if not, you throw it away, right? So don't just trust what's coming into your APIs. Number 8 is security misconfiguration. This is kind of a kitchen sink of best practices. So hardening and patching and turning off services and using encryption and headers and cores and rate limiting and all these kinds of things. We actually have a course called Securing API Servers from my awesome colleague, Anthony. Go check it out. It'll teach you a lot about this. 9 is improper inventory management. Classic example here is version control, right? So if you've got an API at acme.com/API/v3, that's a very common path. When an attacker sees that, I promise you they're going to try V2, V1, UAT, all kinds of different things and see if they're available, right? So make sure you know what APIs you've got running, that they are the right versions, they are fully secured, you've done all your testing and everything else. But make sure you know what APIs you've got running. And then for 10, this is unsafe consumption of APIs. This is really all about third-party APIs. So if you're using Salesforce or Stripe or Dropbox or DocuSign APIs, you got to treat those with the same care and security that you do for your own, right? So do your testing, right? Look for cross-account access and do your input validation and so forth, right? Treat those third-party APIs like your own. Don't just assume they're safe. Okay. So I've thrown a lot of information at you here. We've gone through a whole bunch of examples. We've kind of skimmed through the whole OWASP top 10. And great point there, David, on OWASP too. Thank you for chiming in. So let's go into the third act here, if you will, which is how can we secure our APIs? We're like, all right, I think we've all gotten the point. Like APIs are under attack. These attacks are successful. There's certain patterns here. So when it comes to securing APIs, we think there's really 2 main approaches. There's a testing approach and a monitoring approach, right? So the testing approach is really all about hack yourself, right? It's preventative. It's kind of like the doctor's visit, right? Let's evaluate our own APIs before they go live into production as part of the software lifecycle, and evaluate, right? Run these simulations ourselves, right? Act like, hackers and attackers, and try to find the flaws before anyone else can, right? The nice thing about testing is if it's done properly, you can get really high quality results, right? If you want to find Bola, right, log in as Dan in your pre-prod environment and then try to access Christine's records. There you go, right? If that works, you've got an authorization flaw, right? On the monitoring side, this is looking at live traffic, right? And watching that traffic and looking to detect threats and attacks as they are happening, right? Now, this means your APIs have to be out there live in production, right? This is fundamentally a reactive approach, right? It's trying to protect your APIs as a last line of defense, right? And to prevent, brute force attacks and so forth. And this is critical. You've got to do this. It's typically where your WAF will sit, or you might use a SIM or other types of technologies to watch that live traffic. And typically this is either signature-based detection or statistical anomaly detection, right? Like, we don't normally see this type of spike in traffic or activity at this hour of the day or that kind of thing, right? But we're going to expand on both of these to show you what the challenges and the opportunities are to improve. So starting with testing, I mentioned this stat early on. This is the detail, right? The vast majority of testing we do on APIs, certainly automated testing, is functional testing, positive testing, integration, performance, unit testing. Does it do what it's supposed to do, right? Like in the case of Coinbase, can I sell Bitcoin that I own? In the case of Coinbase, the answer was yes. And that's great. They went ahead and pushed to production. But way down here, 4% security testing, which is really, does it not do what it shouldn't do? Or in the case of Coinbase, can I sell Bitcoin I don't own? Right? They didn't run that test, and it turns out that actually was true. You could sell Bitcoin you don't own, right? So one of the best things that I recommend for organizations is to make your developers and your product owners aware of how APIs get attacked and breached. We don't need them to be security experts, but like, this workshop is great education for development teams. In fact, I've done this session for development organizations where at the end of the session, I've had people say, I already know code I got to fix, right? So let's make them aware of how APIs are getting breached. And here's some food for thought on what kind of testing you should be thinking about, right? Level 1 testing, as I would call it, is kind of basic security, right? Like, do we have our unsecured endpoints? Are we leaving the door unlocked on APIs? You've already seen a bunch of examples where that actually happened, right? And breaches occurred. Are we utilizing incremental IDs like the reset code at Instagram, right? Are we running injections and cross-site scripting in these sort of common vulnerability scenarios? That's level 1. Level 2, I would say, is data-oriented testing, right? So what kind of data is this API accessing? What kind of data is it returning? Is it sensitive? Is there PII information here, right? Are there compliance implications for the information that this API is accessing? And then level 3 is what I'd call logic level, right? So like object ID manipulation. Like, can I convert my Ethereum into Bitcoin? That's an object ID manipulation. Or cross-account access. Can I look at all the records of other Duolingo users, right? Or function abuse, right? Can I take my Bumble account and elevate it to from a free account to a paid account, right? And the main point of this whole slide, frankly, is there's a lot of testing scenarios, attack scenarios that you need to think about and simulate, and you can't get there by hand, right? If you're lucky, you can hire a Corey Ball or people like him who are, super experts. But there is a lot of territory to cover here. So we need better automation. We need continuous testing. We need to shift that testing left into the SDLC so we can find these flaws before they go live. And we'll talk a little more about how to get there. And then on the monitoring side, there's a different set of challenges, right? And thank you, Thanos, for that nice comment. I'm sorry I can't keep an eye on the chat very well here, but I'm doing my best. So monitoring, one of the biggest challenges with API attacks and why we see so many attacks get through the defenses is these attacks, the requests, they look completely normal, right? So let me give you some examples. Here's a SQL injection attack. This is obviously bad, right? The or 1 equals 1 is always true. And what will happen here is if you're vulnerable to this logic flaw, your database will return every user in the database, right? Because 1 equals 1 always for every user, right? Every WAF on the planet should block this. This is obviously bad, no question about it. Okay, great. How about this one? Patch payment 42 status is returned. Okay, what's happening here? Let's say you make an order on Amazon, right? You buy a bunch of stuff and you issue this request to change the status from delivered to returned, right? Meaning, oh, I never returned, I didn't get it, I returned it, give me a refund, right? If you've properly configured your WAF, it should block it, right? That should be blocked, right? There should be some rule that says patch cannot be used to update the status of an order, right? If you've done your WAF properly, you should be able to block that. Okay. How about this one? User ID 10 sends a request to delete transfer 1, 2, and 3. Well, that looks completely normal. I mean, it's not a SQL injection. It's not a function that shouldn't be performed, right? But does user 10 actually own transfer 1, 2, and 3? 1, 2, 3? No way to know, right? And this request is going to go through, right? Because your WAF has 2 milliseconds to make a decision, right? Everything looks good, right? The payload is right, the data type is right, the parameters look fine. There's not enough context to determine if this is a valid request or not, and it's going to go through. And this is the fundamental challenge of monitoring to protect your APIs, right? API attacks look normal, right? Like Trello, Duolingo, all of those things, they look like normal requests here. Okay, so let's double click on testing here, right? Because that's where we think actually there's the greatest opportunity for improvement. So we built this simple graphic, right? So on the vertical axis, you've got common or simple vulnerabilities to complex like logic flaws, right? And across the x-axis, like frequency, like once a year or manual, ad hoc through to like continuous, everyday, continuous assessment. And so for that, those like low hanging fruit, common vulnerabilities, we've got that covered, honestly, right? Organizations do not get breached down here. We don't see SQL injection breaches or cross-site scripting, right? Your SaaS tools, your DAS tools, your bug bounties, they're great at finding these flaws, and we don't see vulnerabilities. We don't see breaches happening down here, okay? But what about up here? This is where the breaches are happening, right? All right, so for finding complex, you're really stuck with like, sophisticated pen testing, hiring people like Corey and people like him, right? Who are very knowledgeable, who can analyze your APIs and run these sophisticated logic tests, authorization tests, and so forth. The challenge is if you can, bring your pen test team in once or twice a year, but you're releasing code 50 times a year or 300 times a year, that's a lot of code that's not being tested. And that's creating this security hole, in my opinion, right? These sophisticated, more complex vulnerabilities are not being detected on every release pre-production in an automated fashion, right? And this is the thing that we've really got to address here. Okay. And indeed, Alamir, big shout out to Corey, always, the godfather of APIsec U. So we went back to this list, right? I showed you this before, and we tried to categorize all these different attacks and try to look for some common threads here. Okay. And this is what we found, right? These top 4 items dominated the attacks, right? And number 1 on the list here is actually OWASP number 4, rate limiting, right? And you might conclude out of this that rate limiting is your number 1 problem to fix. And I think it's the wrong conclusion. Okay. Why? Because rate limiting isn't the core problem. It just makes the core problem worse, right? The core problem is you got an API revealing something valuable, right? If you think about like Trello, if there was nothing valuable there, they wouldn't have tried 500 million times. They wouldn't have tried 50 times, right? The issue here is rate limiting is what gets exploited, or what attackers try to work around in order to harvest data. And as I said, they don't need to harvest data in the next 10 minutes or the next day. They could take 10 months as far as they're concerned. Once they find something that's revealing useful info, they can take as long as they want, right? And so frankly, this reveals the limitations of rate limiting as a defense. You should do it. Don't get me wrong. It's important, right? But don't think you're protected from all attack types because you've got rate limiting in place. And as I said, this isn't the core problem, right? The core problem actually turns out to be the next three, which are OWASP 1, 2, and 3, not coincidentally, right? It turns out 90% of those breaches on the last slide were a result of some combination of OWASP 1, 2, and 3. And what are we talking about? OWASP 1, broken authorization. Can user A access user B's data, right? Or something like that. OWASP 2, are we leaving the door unlocked, right? Or we have some sort of weak authentication that is giving people access to APIs that they shouldn't. And then the key, number 3, excess data exposure. Is our API returning something of value to the user? Think about like Duolingo, right? If I was to query my data on Duolingo, that's fine, right? But if I can also query your data on Duolingo, which is OWASP 1, now I got a breach, right? And this is what we're seeing as the dominant attack vectors for APIs. It's not to say the rest of the OWASP isn't important, very important, right? But if you want to dramatically improve your security in the next day, week, month, go address OWASP 1, 2, and 3, and you have already protected yourself from 90% of those successful breaches, right? And this is why I really recommend we get our developers, our product owners in on this conversation to understand how these breaches are happening, okay? So how do we go about protecting against those? So we looked at this life cycle of an API, right? From definition, which is like, hey, we need a new API that does X, all the way through retirement. All right. And we mapped across this. What are the different security things that you can do at these different stages of the pipeline, right? So in the definition phase, you're all around the whiteboard. Hopefully security is in the room, right? And you're sketching out and designing a new API, hopefully with security involved. Great. Now you move into coding, development, right? So you're coding your API and you're doing all your standard things, code reviews and code analysis, composition analysis, right? Those testing tools will look for your low-hanging fruit, right? Injections, cross-site, coding, bad coding practices, vulnerable libraries, right? That sort of bottom half of that chart, right? That quadrant chart, right? Logic flaws, authorization flaws, well, hopefully you're catching those in the code reviews, right? That's where you ought to be catching them, right? But maybe you missed one, right? So now that flaw makes it into testing, right? And what have you got here? Your legacy dynamic application security tools, Nessus scanning, these types of things. That's gonna, help you with those common vulnerabilities. And if not, then you got to do it by hand, pen testing, bug bounties, that kind of thing. And we've talked about the challenges of the limitations there. But this is where we see the biggest security gap, right? We're not doing a great job of capturing and finding those flaws during the testing phase, especially those complex scenarios, authorization and logic and so forth. And this is what we call the API security gap, right? Between development and deployment, right? This is where we need to catch those vulnerabilities, because after this, now our APIs are in production. They're live, right? And we're relying on the gateway, the WAF, the SIM to detect and block and discover those attacks that are very hard to detect at this stage, right? And this is what we kind of depict down here. Like if you were to try to find OWASP 1, 2, and 3, where's your best place to do it? Runtime is actually quite hard, right? As we've seen, like API attacks look normal and they get through the defenses, right? But if you're doing the right testing, you can absolutely find these API attacks. OWASP 1, what does the test look like? Log in as user A and then access user B's data, right? If that works, you've got authorization flaws. And of course, there's a lot of combinations and permutations to think about, but that's the kind of test you should be running. Broken authentication, go to every endpoint and try to query it without any credentials and see if it works, right? Look for those unlocked doors, and then excess data exposure. Go to, query every endpoint and examine the response. Is there an email address in here, bank account, other sensitive data that's important to you, or PII, right? This is the kind of testing that we really recommend that organizations be out there running. Okay, and typically at this point in the workshop, people will say, "Hey, what like, okay, we get it, Dan. We should be testing. Give us some pointers here." So here are some tools, some free, some not free, that you can go take a look at. You're probably familiar with OWASP, Zap, extremely popular, Burp Suite as well. These are, and Postman for that matter, very commonly used, right? And we here at APIsec, we've actually tried to arm the community not just with courses and education and workshops, but with tooling as well. So we're actually about to release a brand new version of our tool, and I'm looking for some beta testers, some early adopters. So I don't know if Christine or Shelby, you can throw up our link here. Thank you. If you'd like to get access to our new version of APIsec Scan, I'd love to work with you, get your feedback, make sure this is as strong as possible. The nice thing about what this tool does that I haven't seen elsewhere is it will analyze your API and generate all the test coverage. You don't have to write it yourself, right? So that's what's really cool about this capability. So if you want to learn more, if you want to sign up, please check it out, all free. And of course, here's some other tools that you can check out as well. So that kind of brings me towards the end of today's session. I want to wrap up with some, like Dan's top 10 list, if you will. And then we'll share the link to get your certificate if you're interested. So number one is define your API processes. This is really governance, right? Like sit down and get the teams together and talk about, how do we build APIs in our organization? How do we test? How do we run them? Are they, do we have a gateway? What are our documentation requirements? All that stuff should be thought through and defined and published. So you don't have random or ad hoc ways of building APIs. You should know your API environment, all the APIs, right? What's running, what APIs you're utilizing. I talked to lots of security teams that say, we don't even know what APIs we got, right? And they rush out to start buying tools and instrumenting the network. And I've never talked to an engineering team that say they don't know what APIs they've got. So I really recommend we get security and engineering development getting a lot closer together, right? With APIs, the fix for these vulnerabilities is almost never in a WAF rule, but more often in the logic, the application code itself. So we need collaboration between security and dev, right? Make documentation mandatory in your organization. I don't know why APIs get published without documentation. It kind of defeats the purpose. How's anyone going to use your API if there's no documentation? That documentation should be present for every API you create, and it's incredibly valuable for security. It's what informs the security team. Hey, what is this API? What does it do? How should we test it? Right? It even informs those automation tools, how to test your API. Let's train the people who are creating our API so they understand OWASP 1, 2, and 3, if nothing else, right? Let's make sure they can create the most secure, most resilient APIs. I strongly recommend centralizing APIs in a gateway or some sort of common platform, so you don't have shadow and rogue and random ways for APIs to get deployed. Don't trust anything, meaning do the input validation. Don't assume what's coming into your API is legit. Make sure you don't rely on the UI for security. We've seen so many examples of that, right? Attackers bypassing the UI, hitting the API directly. Make sure that you address both authentication and authorization for your APIs. And of course, let's beef up our testing, right? Automate it, make it comprehensive, shift it left, put it into the SDLC. And of course, let us know if you want to learn how to do that. So that's our talk for today. I'm sorry I haven't been able to pay a lot of attention to the Q&A here. If you like this workshop and you'd like to do this for your own organization, we do this. It's free. There's no charge. And you can go and check out the and Christine or Shelby, can you please put up the link there? Yeah, thank you. So if you'd like to do a workshop for your organization, I love doing these. They're really a lot of fun. It's a great way to raise awareness about API risks and best practices in your organization. Invite the engineering team, invite the ops team, the compliance team. And thank you all for joining me here today. If you're interested in getting a certificate for attending today's session, you can absolutely do that. And I certainly really welcome all of you to do that. Yes, Jennifer, the private workshop is free, so please go check out. Go check that out, and you can see the URL there. And thank you all so much. I don't know if there are, oh my God, there's so many questions here. Honestly, what we're gonna do here, just in the interest of time here, is follow up with each and every one of you offline and share with you, we'll follow up with you on your questions, your comments here in the session. And make sure that everybody gets their questions answered here. But really grateful for all of you taking the time here to be part of this. It's a lot of fun doing these sessions, and it's all been recorded. So we'll get the recording out to you if you want to share that or watch later on. But thank you all so much. Thank you, Christine and Shelby, for sitting behind the scenes and making this so seamless. And we will see you next time. Take care, everybody.